Insurance isn't one size fits all. That's why drivers have enjoyed Progressive's Name Your Price tool for years now. With the Name Your Price tool, you tell them what you want to pay, and they'll show you options that fit your budget. So, whether you're picking out your first policy or just looking for something that works better for you and your family, they make it easy to see your options. Visit Progressive.com. Find a rate that works for you with the Name Your Price tool. Progressive Casualty Insurance Company and Affiliates. Price and coverage match limited by state law. Running a business means juggling a lot of moving parts. And when your communication tools can't keep up, things start to slip. Missed calls, slow replies, scattered conversations. They're not just frustrating, they're lost opportunities and revenue left on the table. That's where Quo comes in, spelled Q-U-O. Quo is the #1 rated business phone system on G2, trusted by over 90,000 businesses. One shared business number for calls and texts, so every conversation stays visible, organized, and accountable. It works from an app or computer. You can keep your existing number, add teammates, and sync your CRM, letting you scale without adding complexity. And with built-in AI, Quo logs calls, summarizes conversations, and flags next steps, even after hours. Stop missing customers. Stop leaving revenue on the table. Try Quo free and get 20% off your first 6 months at quo.com/tech. That's QUO.com/tech. Quo. No missed calls, no missed customers.
Hi, everyone. I'm Emily Church, back again for the latest Future Positive podcast. If you've been listening to our first episodes, then you know that each time we speak to some of the visionaries that have set their sights making the future we've seen in movies a reality within our lifetime. Today, XPRIZE founder Peter Diamandis is joined by two of the world's greatest entrepreneurs, both who are now working on medical revolutions that have the potential to solve issues ranging from Alzheimer's and diabetes to organ failure. Our guests are Dean Kamen, engineer, innovator, founder of First Robotics, and famously known for creating the Segway. Dean is joined by entrepreneur Martine Rothblatt, who co-founded satellite radio Sirius XM before turning her attention to the medical world and is now exploring 3D printing of human tissue. So strap in and get ready for the latest episode of the XPRIZE Future Positive podcast.
My first introduction, an American lawyer, an author, an entrepreneur, a founder, the chairwoman on the board of United Therapeutics, former CEO of Geostar, creator of Sirius XM satellite radio, helicopter pilot, G6 pilot, a woman working on her 6th moonshot. Please welcome to the stage Dr. Martine Rothblatt. Now, another friend, a man who is one of the most extraordinary engineers and inventors with over 1,000 patents to his name, the founder of some of the most important organizations, most importantly, FIRST, which is powering our young innovators camp here, the creator of the infusion pump, the iBOT, the slingshot, the Segway, and so much more, recognized by a half dozen presidents. Please welcome one of our trustees, a dear friend, Dean Kamen. Here's my challenge. I'm going to let you guys chat for a bit, and then I want to invite the crowd to jump in.
Awesome.
Good?
Thanks, Peter.
Beautiful.
Well, Dean, it's an amazing pleasure to be here with you and with the iBOT. The iBOT is such an amazing invention. Could you share with us a little bit about what you expect to occur between your invention of the Luke arm and the iBOT at the upcoming Tokyo Olympics?
So, we've had a very good year. We've also had so many people ask us to help make sure that the public understands that you may have a physical disability in terms of getting around, but what most people don't understand is that's only a small part of the problem for people that can no longer walk. Yes, we supply mobility and independence, and yes, a curb is no longer like the bars on a cell, and a stair isn't a set of stairs is no longer a parallel universe. But by being able to stand up, we also give people back dignity. And the folks have now said to us, between our prosthetic arm And this device, we are in the process of possibly opening the next Olympics by having somebody climb in that Olympic stadium in one of these devices, and with that arm, light the torch, which I think could be a very nice thing.
Dean epitomizes, to me, and I think to the entire world, the mantra for all of the coolest inventions of the 21st century, which is that biology is technology. And one of the really great questions that was asked during the previous session was that what are we doing to, support our squishy bodies going into space? And I think that question raises this great idea of looking at biology as technology. Now, a squishy body is made of water, and Peter just mentioned that, the whole planet's made of water. We're water people. The salinity of our bodies is exactly the same salinity as the oceans. So there's a oneness. And what does water need to do? It needs to be pumped. For all of the 20th century and up until now, there was only one very basic way of pumping fluids that made it very difficult to integrate pumps with the human body. But starting a few years ago, Dean invented a revolutionary new pump. It's the first new pump that has literally been invented in over a century. It is as accurate as the body constantly squirts its enzymes and hormones and all the different things that we need, the endocrines need to make a body operate. This pump can do. And maybe, Dean, if you could share a little bit with us the breakthrough, the conceptual breakthrough that let you come up with acoustic volume sensing, merging the worlds of sound and the worlds of liquid to come up with biology as technology.
Thank you for that. Martine is holding a little device. I didn't know she'd want the public to see it yet. We're expecting the FDA to bless this thing very soon in its newest form. They blessed a simpler version of it a few months ago. But that device is essentially solid state. It has no motors, no gears, no transmissions.
I call it the Tesla of pumps.
It has a couple of little nitinol actuators that can move tens of nanoliters. That's a thousandth of a thousandth of a thousandth of a liter, plus or minus a couple of % accuracy. And at those very high accuracies, it's a closed-loop control system that you can put very concentrated drugs or hormones or other things, as Martine pointed out, and still make it small enough to wear it like a patch. 40 years ago, I made the first insulin pumps, and they have motors and gears. And today, 40 years later, most of the companies that make stuff for delivering drugs essentially use that technology. It hasn't changed. This device has the capability to do that, as, again, Martine said, because at those scales, you can't measure accurately by weighing something. That's a thousandth of a millionth of a gram. You can't do it, especially on a moving body. But we use the fundamental laws of physics, a Helmholtz oscillator, and PV equals nRT. And for anybody that wants to know, we'll talk about it later. But basically, we send an acoustic signature across the volume that has these critical delivery elements in it, in the case, remodulin. And by looking at the differences in acoustic signature coming off this tuned cavity, we can measure one part or a couple of parts in a billion, the volume, and then the actuator just proceeds to deliver it according to whatever schedule we put into the software. And we've now proven it out. And as I said, we have approval from it in this format, but we're making a new, simpler to use device that I hope we will deliver an approved product in scale to you in the next few months.
Now, Dean, one of the largest healthcare problems that we face, not only in the United States, but increasingly throughout the world, is diabetes. And many people worry that diabetes is actually going to gobble up a significant portion of our entire healthcare budget. I know that DECA and Lilly have been working together with this device to literally transform the entire, not only the treatment of diabetes, but also the economics. And a lot of cool invention right now is going on how can we get all of this enormous waste out of the healthcare system, and people are inventing new apps that will allow patients and people to keep control over their medical records. People will be able to access their medical, to allow other pharmaceutical companies to access anonymized forms of their medical records, to mine all of this vast biomedical data for new breakthroughs. But maybe if you could talk a little bit about how you envision this tiny, tiny pump that your brilliantly creative mind merged, Helmholtz and pressure equations to come up with. How can this transform diabetes from something that right now costs, tens of thousands of dollars per person to treat to something that could cost literally just tens of dollars per patient to treat?
Well, since it's solid state and it doesn't have expensive motors and gearboxes and all that, we can make those in very large volumes, and it's small enough and lightweight enough that you can wear it like a patch, but it already has a bunch of different radios in it. It will talk to your phone, it will talk to the cloud, and it will talk to a CGM, a continuous glucose monitor that a patient can wear, so that it can in real time import information about what your current state is in terms of your blood glucose, and modify the control algorithm to optimize. And particularly for kids, that 5-year-old little kid goes to the birthday party and wants some of the ice cream cake like every other little kid. And right now, unless they adjust the rate at which their pumps are delivering, or take shots that have been properly determined to be the right amount based on how much sugar they're going to take in, that's a hard thing to ask a kid to do. So we think that by making closed-loop control systems between the sensors and this device and other things we're doing, we will give a much better outcome. And to your point, the comorbidities associated with diabetes, which itself is a pretty expensive situation, but the comorbidities, when you look at a person with diabetes compared to somebody of the same age in our population that doesn't have diabetes, the numbers are staggering. It's a 17 times higher rate in adults of end-stage renal failure, more than a factor of 2 higher in, an order of magnitude of 2 higher in cardiovascular conditions. It's blindness. So we can lower the overall cost because it's much better to prevent a problem than cure it, or than to maintain somebody with chronic treatment. And finally, since it can be made the way we're making it, and since we're partnering now with a big pharmaceutical giant, getting it to people more efficiently is going to even incentivize more people to have closed-loop control, and we hope overall dramatically lower not just the financial cost, but the emotional cost and the human. When you see kids with diabetes, but we're going to lower the misery factor of.
Well, that's beautiful, Dean. And I envision that a lot of those astronauts flying on the rockets, both to space and ultimately, especially to Mars, will be able to address some of Gwyneth's point about hardening our bodies by having one of the Dean Kamen patch pumps on their arm and closed circuiting for controlling their conditions.
So, first of all, thank you for the work that both of you do. I want to make sure we touch a little bit on your vision for electric transportation.
Absolutely. Transmedics went public just last month.
Amazing.
So,
amazing.
So things are really happening, and all of this 3D organ printing and manufacturing is going on in throughout the country, but the epicenter is, thanks to Dean, this place called the American Regenerative Manufacturing Institute, Army, funded by the Army or the DoD in Manchester, New Hampshire, and we have literally dozens of startup companies, students there as incubators, creating all of the different bolts and screws and widgets necessary to manufacture an unlimited supply.
I saw you holding a photo of a collagen 3D printed lung structure.
It was amazing. Holding, we printed the scaffold that you saw there in the video. One of the most astonishing things is we print that scaffold from human collagen that's grown in a tobacco plant. So human collagen is regularly very expensive and, hard to get. Most people use bovine collagen or porcine collagen. But the tobacco plant is pretty easy to genetically modify. So we genetically modified it to spit out human collagen. We do this in College Springs, Texas. And Secretary Perry, the Department of Energy, is a great supporter of the effort. And then we digest the tobacco plants, get the collagen, ship it to New Hampshire, put it in the 3D systems, 3D printers, which, Peter, you introduced me to those folks a few years ago. And now we're actually printing the whole scaffold for the lungs. While in North Carolina, we're growing cells by the trillions now. And my advice to new entrepreneurs out there is, back in the day, it would be like, make nails, make, wires, make, from the 60s, plastic. The thing to make in the 21st century are cells. Cells are like the most awesome tool. That's why I keep saying biology is technology, and we're now growing trillions of cells, and anybody here in this audience can start up doing that as well.
Can we hear it for this amazing entrepreneur? Martine and Dean, you make my heart.
What Martine didn't say is she's one of the 5 founding members of Army, which within a few months of when, with some skepticism, the DOD gave us their $80 million commitment, we were up to, and as of now, we're less than 2 years out, we have 154 members, 26 of the major medical schools in the United States are members, about 125 technology companies, a lot of robotics companies, automation companies. But at our summer meeting, which is only the 3rd meeting we've had of all of these members in New Hampshire, we demonstrated a completely closed system in which we put frozen cells. Once they went into the system at the first phase, for 10 days, it was processed under complete closed-loop control, and out of the end came a 7-centimeter-long ligament bone that was capable of putting into a person.
We're heading towards a world in which we all have a spare set of organs. How cool is that? Let's get some questions going. Can I have the house lights up a little bit?
No Martian should be without them.
Yeah.
Yes, honestly. Here we go.
Yeah, your inventions are incredible. Well done. But let's say, hypothetically speaking, that diabetes is caused by an abundance of sugar in your body. Can your device be altered in some way where a family or any human being of any age could have a device that says, whoa, hold on, you ate too much sugar. Stop, now you're on the verge of getting diabetes, or something in your diet is really screwing you up. You're going to become a diabetic. Stop now.
So that might be an intermediate, exciting thing to do. But let me tell you, for diabetes, I'd like to put myself out of the pump business. For dialysis and people with end-stage renal failure, I'd like to stop making that stuff that took us 10 years to develop. For people that might have a broken spinal column, they don't have neurons that are working anymore. I'd like to put myself out of the iBOT business. And working with Martine and now Army, if we can make cells that are beta cells, islet cells, we can make a whole pancreas for that kid that might have developed or will soon develop diabetes. We'll just give them a pancreas. No more pumps. You'd rather cure this problem than chronically treat it. We'd like to grow kidneys and eliminate the need for dialysis. We'd like to grow the ability to make the whole neural network of the body replaceable when there's damage. The bottom line of all that we're doing, look, we now have a healthcare system which basically is chronic care. It's the worst possible, it's the most expensive, and it's the least desirable. At the rate innovation will keep going, I hope, because there's some real leaders, you're looking at 2 of them, nothing's going to stop innovation. People have tried, believe it or not. I think inertia of society and unintended consequences, we try to make little steps, frankly, like the one you're talking about. If you understand that the rate of innovation is going to keep accelerating, and people and companies and governments have to understand you only have 1 or 2 choices. You can be on that bus of innovation, or you're going to be under it. And I think we should stay ahead of all of these issues and think big. And I think from here on in, instead of thinking about how to treat a condition, we should think about how to eliminate it.
What's your charge to the audience here?
If you believe in innovation, the thing we need more of now than ever is innovators. Yeah. And the way we're going to get that is the adults of this world that get it, that care, are going to devote a little of your time and a little of your energy to convincing kids, particularly girls, that science, technology, mathematics, and engineering are every bit as much fun, every bit as cool, and way more accessible than getting passionate about sports and entertainment. We love sports and entertainment. We've turned it into a sport with FIRST. The only difference between our sport and all the others, besides that every kid can play, the only other difference is our sport is the only sport where every kid on every team can turn pro. But if this world doesn't start generating a whole lot more kids that have the tools, the courage, and the right kind of attitude about developing technologies to use as a tool and not a weapon, we're all going to be toast. We will be overcome by one catastrophe or another. Not the ones we worry about now, the ones that we aren't even smart enough to think about now. As Roosevelt said, we cannot build the future for our kids. We better build our kids for the future. And as Einstein said, and this is more important, the world is not a dangerous place because it has evil people. It's because it has good people that do nothing. And we got to stop that, and we got to show real leadership, and we got to create a generation of kids around this planet that know how to communicate, cooperate, and solve their problems together, instead of learning by tradition how to keep imposing the same self-inflicted wounds as they've done for 2,000 years. Those days have to end.
Another question.
I'm very impressed with what I'm seeing what you're doing. So I'm wondering, how far away are we from more complex organs such as hearts, and what are some of the things people maybe in this room can do to accelerate that?
So you probably have seen the videos of the Israeli group, which has already successfully grown a small rodent heart. So the proof of concept is there. I don't think that there's any limitation other than the engineering challenges in scale up to being able to grow a more complex organ like a human heart. In addition, another whole avenue which is possible is to grow human hearts within pigs. Pigs have been exploited from time immemorial. Americans alone eat over 100 million pigs a year. And that also within America, there's about 1 million people each year who die of end-stage heart disease. So just 1% of the consumed pigs could provide a replacement heart for every single person that needs it. What's necessary to do there is to solve a really cool Rubik's Cube of a puzzle. There are humans and pigs diverged from each other about 100 million years ago. Despite that fact, the pig's heart and the human heart are almost exactly the same size and function almost exactly the same way. There are anywhere from maybe a half dozen to perhaps 3 dozen genes specifically relating to immunology, a little bit relating to hematology that differ between the pig and the human. So the people that can figure out how to change those pig genes into human genes will have opened up for themselves an ability to manufacture hearts as easily as people manufacture bacon.
Wow. Next question.
If we do a better and better job at eliminating diabetes or vascular disease or cancer, we're just going to live longer. But unless we knock out Alzheimer's and related dementias, it takes people down, and they'll just be taken down for decades and decades. So how would each of you solve for Alzheimer's disease?
So the first thing I'll tell you is I'm not a microbiologist or organic chemist, but I've been talking to a lot of those folks, and it is staggering how much, and the rate at which they're learning, but how much they already know. And sadly, I think a lot of the last couple of decades of trying to essentially treat the disease, they've looked over the decades now since Alzheimer's named it, which is what, or discovered, that's why they call it that. They decide, oh, there's serum amyloid, there's stuff in the brain, let's figure out how to chelate it out. Every single drug that's been introduced to try to do that in either stage 2 or stage, has failed. Now people are realizing, because when you see all that stuff in that cadaver's brain, you're probably looking at the result and not the cause. It would be like showing up at a house that burned down, and if every house that you've ever shown up that has burned down, there's this black charred stuff, you would conclude the black charred stuff is what caused the house to burn down. No, it's the result. So there are now credible groups that are saying, we know what the cause is, and let's stop looking at the effect. Let's not worry about chelating out of the brain that's got these things. Let's figure out how to do the development work so that the adults that start showing the and the things that cross the blood-brain barrier that end up causing dementia and dysfunctioning of the brain. Let's get those to stop happening. Let's make those brains or those people have the same lack of certain things in their blood that they don't get dementia, these other people do. Let's figure out how to prevent it, not cure it, not treat it, let's prevent it. And that is happening. And these people in Washington that are all worried about 20 years from today, we're going to be bankrupted by everybody having Alzheimer's, remind me of the same cynics that probably in the 1920s, after we invented iron lungs to keep people with polio, I was saying, but every year millions of people get polio. In the next 20 or 30 years, we're going to bankrupt the country because everybody's either going to be in an iron lung, which nobody wanted to be in, or they're going to be treating people in iron lungs because you took 4 people. None of those people sat around in the 1920s and said, yeah, no, this was a stepping stone. We're keeping on. But you see, there'll be this guy, Jonas Salk, in about 20 years. He'll figure out how to scratch his skin, do this, and we'll eliminate this disease for $2 per person. You got to stop thinking about the never-ending doom and gloom of how bad things will get if we stop innovation where it is today and extrapolate forward. Let's extrapolate forward how we're one by one going to take on these big challenges. That's what XPRIZE is about, and eliminate the goddamn problem. And we're going to do that with Alzheimer's.
So thank you. So building on that idea, I'll share with you my own outside of the box preferred approach or preferred paradigm for addressing Alzheimer's. It falls under the rubric of what I think is one of the most exciting areas of 21st century innovation. It's called bioelectronic medicine. And this is taking advantage of the fact that the human nervous system touches every single cell in your entire body. But in fact, we're really hugely ignorant about the human nervous system. We've cracked the human genome, but nobody has tried to crack or hack all of the different waveforms and signals and amplitudes and frequencies of the human nervous system. Yet we continually send signals up and down the brain throughout the body. Recently, a company that I just started called String, based on the discoveries of Kevin Tracy, Chief Medical Officer of Northwell and kind of the father of bioelectronic medicine, has been developing a headset just like a Beats music headset that you put over your ears. Now, the reason for that, the largest nerve in the human body, and in fact, you could say the entire human body is parasitic in service of this one nerve, is called the vagus nerve. It wraps around your heart, it wraps around your lungs, it wraps around your gut. It comes all the way up into your brain, through ultimately to your hippocampus, and we are built around the vagus nerve. It's been largely ignored. But recently, people like Dr. Tracy have shown that with a tiny bioelectronic implant, a little bit larger than a large grain of rice, put on this vagus nerve, that he can control Crohn's disease as good or better than with these very, very expensive, tens of thousands of dollars a year, tumor necrosis factor antagonists and other expensive biologic drugs, just with a little electrical signal that's going into the vagus nerve. Now, the vagus nerve, nature was awesome for us because it brought the vagus nerve out of the body, out to the skin in only 2 places, in the cymbal conchae, or the inner loop of the left ear, and the cymbal conchae of the right ear. So by putting an electrode at these little places on your ear, you can address a vast number of medical conditions. One of the things that's been shown that vagal nerve stimulation does is it rebalances the parasympathetic nervous system and the sympathetic nervous system. Now, the sympathetic nervous system is our fight or flight. It's an overstressed reaction that some researchers believe, in fact, gives rise to Alzheimer's, because the older you get, what happens is the sympathetic nervous system becomes more potent than the parasympathetic. The parasympathetic, I think of that as kind of, pause, rest, zen, but that gets lower and lower as we get older. So it may be that this black char from the amyloid plaque that we see is just the result of an extended decade after decade overstressing of the sympathetic nervous system that can be completely 180'd around just with a few minutes each day of a little electrical nervous stimulation through the ears. One of you guys out there are going to invent that. and it will work. There will be a different signal and a different waveform for Alzheimer's, another one for insomnia, another one for depression, for heart disease, lung disease. The ears will turn out, I believe, in the bioelectronic paradigm to be the pathway to our health and the pathway for dozens of breakthrough innovative inventions.
Amazing. Amazing. Hey, Martine, what did you get your doctorate in?
Medical ethics.
In ethics, medical ethics. Amazing. Guys, thank you so much for your inspiration. Dean Kamen, Martine Rothblatt, two amazing innovators.
Hey everyone, thanks for listening today. And next time, acclaimed author Kim Stanley Robinson, known for his scientifically backed approach to science fiction, talks with XPRIZE's own Peter Diamandis about the role of AI and quantum computing in advancing humanity's goals.
Hi, I'm Anusha Ansari, astronaut and CEO of XPRIZE, a global future positive movement of over 1 million people and rising, tackling the world's grandest challenges in exploration, environment, and human equity. We'd love for you to join us. Check us out on your favorite socials and find out how you can support, sign up, or join a team at xprize.org.
You're listening to this podcast, so I know you've got a curious mind. Here's a helpful fact you might not know yet. Drivers who switch and save with Progressive save over $900 on average. Pop over to Progressive.com, answer some questions, and you'll get a quick quote with discounts that are easy to come by. In fact, 99% of their auto customers earn at least one discount. Visit Progressive.com and see if you can enjoy a little cash back. Progressive Casualty Insurance Company and Affiliates. National average 12-month savings by $946 by new customers surveyed who saved with Progressive between June 2024 and May 2025. Potential savings will vary.
Acast powers the world's best podcasts. Here's a show that we recommend.
A lot of work advice sounds good in theory, but falls apart when you actually try to use it. I'm on a mission to change that. I'm Molly Graham, a company builder and the new host of Work Life, a podcast from TED. I've spent my career inside fast-growing companies, and one thing I know for sure is that work is messy. In this new season, I'm excited to share my conversations with founders, operators, and creatives about the real story behind their shiniest successes, the lessons that no one ever posts on LinkedIn. Listen now on Work Life, wherever you get your podcasts.
Acast helps creators launch, grow, and monetize their podcasts everywhere. Acast.com.